Hey, how's it going? I've been working on this problem for about 3 hours and it's ruining my life. But I just can't let it go because, I mean, I've done thousands of Leetcode problems and I'm pretty sure that my technique should work. I just keep making clerical errors. So, 3 hours. Let's figure it out. Leetcode 3306, count of substrings containing every vowel and k consonants, level 2. You're given a string word and non-negative integer k. Return the total number of substrings of word that contain every vowel a, e, I, o, u at least once and exactly k consonants. Okay, so what am I doing? First thing I'm doing is converting every character that is not a vowel into the character C. Oh, sorry, that was supposed to be part of the selection. Alright, then I am creating a numerical sorted index list of where we find each of the characters A, E, I, O, U, and C. Alright, now this is just pure pedantry. I am making sure that my data set is correct. This is not useful code, and I'm not going to leave this in here. So, let's see. For I in range 4 to length of word, right? All right. So we need to ensure that in every case so you know what, I might actually want this letter to index like that. Alright, so 4 vowels in A, E, I, O, U. That's dumb. That is so dumb. Or J in range 5. There we go. Here's our vowels. All right. Okay. The minimum is going to be I, which obviously doesn't make sense. We need to push it so that we have every one of the vowels that we need. Okay, so ARR equals indices of J. If not ARR, then min equals -1. Okay, if min is less than 0, then continue. There's nothing that we can do. All right, but usually that's not going to be the case. Or at least for the cases that we want, that's not going to be the cases. So, otherwise, else if ARR of 0 is greater than I, then min equals -1. In other words, if the first vowel is to the right of what is supposed to be the end of our substring, then there's nothing we can do. Okay. Now I think that we can delete the indices as we move further to the right. All right. Else, yeah, we'll take a look here. If ARR of 0 is greater than I, yeah. So while length of ARR is greater than or equal to 2. It's greater than 1. And ARR of 1 is lesser than or equal to I ARR dot pop 0. So we're going to get rid of the bottom one if we don't need it anymore. You know what? I feel like this should go here. While length of ARR is greater than 1 and ARR of 1 is lesser than or equal to I, ARR dot pop 0. So now we know that we're looking at the smallest one. So if ARR of 0 is greater than I, then there's nothing we can do. If there's no entries left, then there's nothing we can do. Otherwise, min equals min of ARR of 0, comma, min. Is that confusing? Should be MV. Just make sure that you changed it everywhere. MV, 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 oh my god. Okay, MV, 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 find min. Oh, good thing I did that check. Okay, if it's less than 0, then we're hosed. We have to treat the vowels separately than the consonants. Okay. So, the starting position cannot be higher than MV. The ending position is defined as I. Okay. Now, just because I've screwed up so many times, I just want to substring equals word MV to I plus 1 for CH in AEIOU, assert CH in substring. Obviously I won't leave that in there, but I just want to make sure that my code works right. Okay, and it does. Thank God. All right. Now, what we want to do is we want to find out how many consonants there are, and I think we need an accumulator for that. So we are going to say consonant accumulator. That is consonant accumulator equals 0 plus list accumulate. Why isn't it turning? Int I equals C for I in word. Print now I have to remember that it's off by 1. Must be byte-like objects, not generator. List accumulator. Int I equals C. Helps if you get your parentheses right. All right. So 0, 0, 0, 0, 0, 1, 2. So it shows you how many consonants there are to the left of the given position. So we have boom, 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 boom. You know what? I think the off by 1 was confusing me earlier. Let's get rid of it, even if it makes the subtraction a little harder. I don't want to screw it up. Okay. Okay. Current consonant count equals, well, it's going to be consonant accumulator of I minus, well, the good thing is that we know that this is going to be ending on a vowel. So we don't need the 0 there. Minimum value. And I'm sorry. It's been 3 hours. I don't trust myself at this point. Word. I shouldn't have deleted. I plus 1. Okay, assert substring dot count C equals current consonant count. I don't trust myself because I've just made too many clerical errors at this point. Okay. Apparently this is working. You know what? Instead of deleting this every time, I'm just going to leave this while I'm debugging. And then if I keep wanting to refer to the substring, then I can. Okay. So now, obviously, if current consonant count is greater than what? Is greater than K, then there's nothing we can do. We're done. Because then there's too many consonants in there, there's nothing we can do. Now the next case is that it might be too low. So we need to jump to the next place. If current consonant count, and I think that we should put it up here. If consonant accumulator of I is lesser than K, then the number of consonants isn't high enough in the string. So there's no way we're going to be able to satisfy it. Not enough consonants yet. Really? Did I spell that right? No, I don't know. Yet. Okay. Which means that, yeah. Okay, so what we need to do is we need to know the first locations. I'm getting PTSD, but okay, first consonant equals like that. For I in range length, consonant accumulator. Okay. If consonant accumulator I in first consonant. No. If it's not in it, then the first time that it appears is I. Right? Okay. If it's less than K, then we need to increase it All right. And we're going to do that by moving MV to a lower value. Okay, original MV equals MV. Assert MV is less than original MV. Right? All right. If current consonant count is less than k, so original MV equals MV. Now we want first okay, so if we're at 2 and we want 2, then we need to move to 1. Right? MV equals min of first consonant count. Well, no, it's not min. We know it's going to be lower. First consonant of where's the accumulator? The consonant accumulator of I it seems like if we're ending on a consonant and k is 0, then that is a special case and we need to address that. So let's address that right here. If word of I equals C and k equals 0, then we're treating that as a special case. Cannot end on a consonant if no consonants should be in final string. All right. Okay, move MV to a lower value. I feel like this might have taken care of that, but I just, I don't want any confusion, any funny business down here. So MV equals first constant accumulator I minus k plus 1. So if we're at 2 in the accumulator, and there's supposed to be 1, not plus 2, plus 1, then minus 1 plus 1 is going to be the first instance of 2. I think that that's right. But if we need 2 consonants, then we need to go to the first instance of 1. So we would subtract 2 and add 1. That would take us to the first 1. Okay. So let's take a look here. To do, remove this. So substring. All right. Substring count of C should now equal K, and substring, well, no, and moving to the right 1 position should no longer equal K. Did I do it right? Oh my God. I mean, if the problem is this simple, why is it taking me 3 hours? This is ridiculous. All right. Okay. Okay, let's see here. if it's less than k, all right. Now, the current consonant count should now equal k. Now that we are here, the current consonant count should equal k. Okay. Now we want to see if we can push it further to the left. See if we can push further to the left. Okay. So MV is rightmost satisfying location. Okay, so we are going to say left equals MV, but left doesn't equal MV. We want to move it just like this, right? We want it to be one more than I feel like there's going to be a special case if the first letter is a consonant. But let's not concern ourselves with the first case. If it starts with a 1, actually we can do this. We can do this. If 0 not in first consonant, in other words, if it started with a C, then first of 0 equals -1. Okay, now it's clean. Now we can use it. All right, so left equals, all right. +1. Yes. All right. No. Let's do it. I'm sorry. I am jaded. So left to I plus 1 equals k. And then if left doesn't equal 0, have I fucked it up? That's the question. Okay, this is why we put the assertions in. So let's see here. Count. This is why we're checking. Substring equals word left. So this is working. left word I see what it's doing. Okay, so A-E-I-O-U, A-E-I-O-U. So K is 0. It was at 0, we wanted to stay at 0. Well, in that case, cons ACC, the first 0 would be 0. Should this always be -1? If left doesn't equal 0 and K doesn't equal 0. All right, no assertions. Okay. I wish that there was an example where the... Well, I mean, I can make an example. I can... How do I copy the test case? Add test case. Diff... No, not diff. Yeah. There we go. So, I don't know. A-E-I-O-U. Yeah. Make me a string, please. A-E-I-O-U C secrets dot rand below 6 or I in range 300. There we go. And we'll make sure that somewhere in here A-E-I-O-U is always in there. Okay, run. I just want to see if it's going to give me an assertion. Okay, cool. No assertion. So in that case, CNT equals 0. And we should be able to go starting anywhere from left to MV. So CNT plus equals 1 plus MV minus left. And then just return CNT, right? All right. Find to do. To do. To do. Find word. Find substring. Find assert. Okay. It's still printing. Print, no prints. Submit. I swear to God if this times out. All right. Beats. Okay. You know what? That's fine. It passed. And that's it. And that's all.